And boom. There we go. All right. A hill and a gondola line are 20 feet above the ground that goes up the hill. Both have a slope of 1/2. What's the geometric relationship between the hill and the gondola ride? What do we look about these two red lines? They look to be parallel. Okay. If their slopes are this, what can we say about the slopes of parallel lines? They're equal. Two non-vertical lines are parallel if and only if, biconditional, if and only if their slopes are equal. Their slopes have to be equal. Now, if they're vertical lines, what's the slope of a vertical line? Not zero, it's undefined. We can't say what the slope is. So we have a special case for vertical lines. If we have two vertical lines that are parallel, okay? Two vertical lines are going to be parallel. But if you're non-vertical lines, the slopes have to be the same to be parallel, okay? So looking at this picture, zoom, okay? Now I got to change colors to blue because these are red lines. All right. I want to know, are M and Q parallel? Well, what's the slope of M? So we're going to go right there and right there. What's the slope of M, Jordan Peterson? 1/3. Okay. Let's look at Q. I'm going to go right there, it crosses, and then it crosses again right here. What's the slope of Q, Olivia Meehan? It's going to be a positive because it goes up from left to right. So you're going up and to the right 2, or to the right 5. So it's going to be 2/5. Are those slopes equal? No. Are those lines parallel? No. They kind of look parallelish. If you just take a glance at it, you'd say, yep, they're parallel, but they're not. The slopes are not the same. They're not parallel. Okay, let's look at K and N. Let's look at the slope of K. K, it goes through right there, and then right down here. Okay, so we go down 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4. So it's -5/4. The slope of N right there and right there. We go down 4 into the right 3. Nate, are they parallel? No, because their slopes are different. Okay, what's the slope of these two lines? What's the slope of these two lines, Amelia? 1/3. They're both 1/3. So are they parallel? Yes. N is parallel to M. All right. Now let's talk about perpendicular. Two non-vertical lines are perpendicular if and only if their product of their slope is -1. Okay? So they have to their slopes have to multiply together to be -1. And I'll explain more about that when we hit an example here in a second. Also, they're parallel. If one is vertical and one is horizontal, it's parallel. Okay? Because can you multiply a slope of 0 times a slope of undefined and get -1? No. But we know that a vertical line and a horizontal line are going to be perpendicular to each other. Okay? So we're going to multiply to get a slope product of -1. So let's look at these. All right. So the ones that kind of look perpendicular are K, this one here, and J, this one here. They kind of look perpendicular. So let's look at the slope of K and the slope of J. Slope of K goes through here and it goes through here. So what's the slope of K, Braden? 2 over 3. Now I'm looking for the slope of j. Now I know j goes through this one right here and this one right here. So what's the slope of j, Aiden? Negative 3 over 2. If you multiply 2/3 times negative 3 over 2, you get negative 6 over 6. What's negative 6 over 6? And lines are perpendicular if their slopes multiply to be negative 1. So k is perpendicular to j. You use an upside down t to say perpendicular. Okay? What I look for is this. When you flip over a fraction, it's called a what? Starts with an R. I love it when people know math words. These are reciprocals of each other. But see how they have opposite signs? So if they're opposite reciprocals, then they're perpendicular. If the slopes are opposite reciprocals, then they're perpendicular. Okay, let's look at L and H. H and L. Woo. H and L. L, it goes through right here and then again right here. So what's the slope of L? What's the slope of L? I go up 1, 2, 3, 4, 5. So the slope of L would be 5 over 2. H goes through right there. Boy, where does it go again? Well, let's say I can't figure that out exactly. What should the slope of H be to be perpendicular? Negative 2 over 5. So if we go back 1, 2, 3, 4, 5, and up 1, 2, does it go through this point? No. L and H are not perpendicular. L and H are not perpendicular because they don't have opposite reciprocal slopes. Okay. Are these perpendicular? Well, we've got there and there, and we've got there and there. Slope of M, this one coming right here, is what, Haley? M, this one coming right here. What's this slope? We go up how far? From here to here. 1, and over to the right? 3. So the slope is 1/3. Okay? What is the slope from here down to there, Ella? What? Or it's negative 4 over 1, right? Are they opposite reciprocals? No. So they are not. M is not perpendicular to N. Okay. All right. So now we're going to draw a line through this point and make them parallel. Okay, and I want to know what is the equation of that. What is the equation? Well, y equals mx plus b, right? What's the slope of the red line, line L? Tate, 1 over 2. It's the number in front of x. When y is alone, the slope is the number in front of x. So y equals 1/2 x plus b for the parallel line. So it goes through 4, 1. So I know what x and y are. Okay, what's y? 1 equals 1/2 of 4 plus b. What's half of 4? 2. If I subtract 2, b equals negative 1. So the equation of the blue line here is y equals 1/2 x minus 1. Y equals 1/2 x minus 1. They're parallel. Okay, so parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. They multiply to be -1. I am going to put out the assignment. I'll walk around and help you. Most of the last class had questions on 12 and 13 because they struggled with this part right here. So I will leave that on the board for you. But if you need help, I'll help you. Okay? So get to work on your assignment. It is already out there for you.